Yeah, so my name is Jeroen. I'm from originally a Java developer. Also did a lot of Scala in the past, and yeah, since like 1 year, 2 years now, dove into Kotlin as well. Yeah, so I'm very happy to be able to conduct this training today. Very excited about it. I think we have a nice menu for you to pick from. So you can basically choose the topics that you're interested in, and yeah, and dive into that. Yeah, we will introduce you to the platform soon, where you can do that. Yeah, so over to you, Urs.
Okay, yeah. Thanks, Jeroen, for introduction. My name is Urs Peter. I also started long ago with Java, then I moved on to Scala, and then with a detour went to Kotlin, and very enthusiastic about Kotlin. For years I'm programming it. I can call myself certified Kotlin trainer. So far I'm the only one in the Netherlands, which is quite cool, of course. Today we offered you a program, as already Jeroen said, with a lot of variety. But as said, it's more for intermediate advanced purposes. So I see, I think the poll is shared now, eh? That's correct?
Yes, we can see the results. Yeah, I think you all can, right?
Indeed. I see 6 beginners and 6 or 7 intermediate expert. And we have to see how we deal with beginner, because as said, we assume that certain constructs already more or less you're familiar with. And of course, the aim of this course is that you learn something, not frustrate yourself. But okay, I think we will walk through the program, and then you can form a picture yourself, what you can expect of this course. We are there to help, of course, to make it for you a nice experience, and hopefully you take a lot of cool and distinguishing knowledge home. So I will start with the content, and then Jeroen will take it over and show you how you have to set up our development environment so that you can do all the challenges we prepared for you. So now I will share my screen. I assume that you can see my screen now. That's correct. Can you see, Jeroen?
I can see it. So okay, I can see it, yes.
Double check, yeah. Because we are still, of course, talking to a tool. I know there are people behind it. But for us, it's still a tool. Okay, so is this workshop for me? As said, the workshop is built for intermediate advanced levels, which implies that the features we are naming here, like basic O features, how you make class interfaces, a bit of null safety, functions, collections, when expressions, and so on, you are more or less familiar with. If you're not, it's probably a bit challenging. On the other hand, you can give it a try. We are there to help. We have a nice chat room over there, and we can quite easily, you can easily ask you questions. And we also can, if needed, walk you through certain subjects step by step. So we will more do an explanation than you just doing the labs. So what are we going to treat? The subjects we've selected are really the bit more advanced things you can do with Kotlin. The first one is making type-safe builders. So you can, with a few language constructs of Kotlin, you can create whole DSL-like structures. And the good news is, once you know about 3 to 5 of these constructs, you're really able to make impressive things out of it. So with a few language constructs, you can do really considerably cool stuff. This will take about 45 minutes. On the right, you see how much time you will more or less need to go through it. And of course, you always can skip certain parts if you want, so that you can move on in case you think, I want to learn something else. The second part, and I see this also in the poll, coroutines, is quite an interesting topic. We will cover all of it. So the basics, what are coroutines, how to relate to threads, start really step by step. So I think when you are a beginner, maybe that's even a better one to step in than the DSL and type-safe builder, because type-safe builders builds more on constructs you should know in Kotlin. Then we look at interop, because you have a lot of async reactive frameworks out there, and they somehow need to interact with coroutines. So there we'll also have a nice lab for that. And then we go to a bit the higher level primitives, which you probably use less, but which are extremely powerful, are channels and flows. So once you have the basis of these constructs, then we look at Spring Boot, Reactive Spring Boot, namely, so WebFlux. And I see that 5 have no experience, 5 have a little experience with WebFlux. So yeah, also there the experience level is not that high. It's the reactive extension of Spring Boot. And the nice thing is when you combine them with coroutines, your code is getting so much more simple, readable, maintainable. This you can experience yourself. So you will write some reactive database access, so DAOs or repositories with coroutines, make some REST calls. Then you will port your controllers to a coroutine space. And what you then will do, you will transform Java-based classes to coroutines. So the Java classes are based on WebFlux, and then you make Kotlin coroutines out of it. And in the end, that's the kind of the big final. You combine all the knowledge you've gained today, and you can create streaming APIs with flows and channels. So, as said, we would like to keep it as interactive as possible. If you're struggling, don't wait too long. Put it in the chat box. If more people struggle with the same thing, we make it interactive. We will probably explain certain subjects for the ones that are interested in, and for the rest, you actually can work yourself, because the whole program is set up in such a way that you have some slides which capture all the relevant information you need to complete the subject. So walk carefully through the slides. You shouldn't actually Google. Shouldn't be necessary to Google. All the information is there, so read it carefully, and then you should be able to come quite far. And that's that. If you struggle, there is a chat box, and we are really glad to help, because in the coming 2 hours, you also want to do something, right? So then we wish you a lot of fun, and I give now the word, hand it over to Jeroen, who will show you how you have to set up your development environment.
Yes, thank you, Urs. Yeah, so as you can see, we already shared this link into the chat as well, and it's also on the slide that Urs just shared. So this link will take you to our interactive web IDE. I will now also share my screen, and yeah, then hopefully you can follow along where I introduce you into the environment. So when clicking on the link, you should go to a screen that will look like, you should see a screen like this. I hope it's visible. So basically, you just have to press add to my study room here. This is Instruct, which is a tool basically to build trainings and host a web IDE. Our training should be listed here. It's called Kotlin JSpring Intermediate Advanced. So you open it, and yeah, there you see a general introduction to the training. The only thing you would have to do is press Start Track, and that will get you started. So while the environment is being set up, so there's being some preparation done to prepare your web IDE, I can walk you through the ins and outs of the platform, all you need to know. So you will, once the setup is done, you will see a screen like this. So you will see a screen with different tabs. There will be slides where you can find like the course material, the theory, let's say. There's a code editor tab, and there are like 2 terminal tabs. In the code editor tab, there you will do your exercises, and on the right-hand side is a description of what needs to be done in the exercises. Most of the information regarding the exercises will be in the code itself as a code comment. Your code editor tab will look similar to this. So it's a VS Code instance. There will be a Kotlin language server installed once you open the first Kotlin file. So that's in the first step. That's a good thing to do, to open at least one Kotlin file and make sure that the Kotlin language server is is installed. That's also in the description of the first challenge. Yeah, basically here you can write your code. In the comments, it's indicated what needs to be done to pass the challenge. And also what's very important is you can run tests, the unit tests. So in all challenges, you would have to make sure that the unit test pass to complete the challenge. And there's a button on the bottom of the screen. It's circled here in red. It says run current test. This button will be visible once you have a test file opened. And when you press it, it basically runs the current test file using Maven. And when all the tests pass, so then you completed the challenge, then you can press the check button when all the unit tests succeed, and that will take you to the next challenge. If there are test failures, you can see it in this terminal output window. So now you can always access these instructions through the Notes tab on the top right of your screen. So when I press start now, I will go to the first challenge. And here, this is basically the environment. So here you can scroll to the slides at your own pace. There's the code editor tab is here. So the first thing I would do, this is the first challenge. Please navigate to the VS Code editor tab. That's this, I just did that. Open the Kotlin source file. So I will just open, let's say, the first challenge. Now you see a pop-up that it tries to install a language server. So you press OK, continue. If somehow you missed that pop-up, you can still go to this bell icon and it should still be there. Because it's important that you install this, otherwise you won't have any code completion available. And that can be quite challenging. So if everything is well, of course, it needs some time to index the folders. When this is done, basic code completion should work. You can also by command clicking, in my case, on certain functions. So for instance, if I want to go to the definition of, let's say, where is it? Let me open the test file. Let's see if it works. Maybe that's not. Yeah, so by command clicking, I can now navigate to a different class. So that should help you. And basic code completion is available. So, for instance, if I have a string here, hello, I press Ctrl space. Let's do that again. Then, yeah, string length is available. So after checking this, basically you're all set up. You can go to the first challenge. Well, this was not much of a challenge, of course, but at least it's good to verify. And well, you can go to you can choose to follow this course in order of how the challenges come. So as Urs introduced, the first topic would be the builders and the DSLs. What you also can do, you can at any point in time, you can go back and you can basically choose from this menu here what specific challenge you're interested in. So I saw in the poll that there was a lot of interest into coroutines. So you can also choose like to start with the coroutines exercises straight away. If you don't want to take the builders and DSL challenge, that's totally fine. You can we're here for you, right? So use your time efficiently. So for example, let's say I want to do the coroutines interoperability course challenge, sorry. Then I press the skip to button. This will take, again, a few seconds. And then you can immediately go to the coroutines interoperability challenge. There will be a small setup again, but it will be much shorter than the initial setup. When I press start, now you're also immediately at the right slide that will contain the content that you need to complete this challenge. So from here you can navigate at your own pace and make the challenge. All right, I hope this was a bit clear, and I hope that with these instructions you will be able to to go at your own pace and take the challenges. Of course, we will be here, as Urs mentioned. If you have any questions, please put them in the chat, and we will try to help as quickly as possible. And most importantly, I wish you a lot of fun doing these challenges. And please, we will also share a survey at the end. It would be really nice if you will be willing to fill that in, because it will give us a lot of feedback to see how you like the course and to learn what we can still improve. So I will stop sharing my screen now, and have fun.
So thank you, Jeroen, for your detailed information about how to set up the web ID. Since we have quite some beginners in the course, and as I said, it can be quite challenging, I think it is wisely, once you have set up your web ID, that we'll walk through some of the slides. And I think I would advise to choose the Coroutines subject, because most of you have marked this as the one you would like to know more about. So it would be nice if you could, on the chat, let know if it worked, or if you have trouble. Also, please let it know, so that we get a sort of impression that you're all up and running more or less, and we really can get to work and not struggling with setting up our environment. So I will wait maybe 4 more minutes, and then we will do, for the coroutines, I will do an explanation. Maybe Jeroen will do another subject, but let's start then with the coroutines.
Yeah, I see. I did a quick check. I see most of you are able to start working on the challenges. I see a lot of you are already picking up the builders challenge, so that's good to see. But yeah, please let us know if you run into problems, if you get stuck. Please let us know through the chat.
And as an additional side note, the builder challenge is quite challenging, especially when you're new to Kotlin. So of course, you will learn quite important constructs which help you to understand coroutines, even though you don't necessarily need them. They'll help you. So yeah, it's up to you, of course, to make a choice, but you can also switch to coroutines if you think this is the subject you're more interested in, especially when you're a beginner. I think when you're intermediate level, that's perfectly fine. When you're a beginner, yeah, maybe coroutines is a better subject to start with. Yeah, I think it's time to walk through the slides for coroutine, just to give you probably some additional explanation of how these things work than just looking at slides. Up to you, of course, if you want to listen. If you don't, then you turn off your microphone. That's the nice thing about this setting, and just continue working. If you think it might help to know a little bit more, some extra information than what's only on the slide, then stick with me. I'll share my screen. Okay, concurrency with coroutines. What you see on the first slide is an example in Java.
1 second, Urs. I don't see your screen yet, or at least not the right screen. Could be me, but...
Thank you, Jeroen. You always need to click many OK buttons till you so far think now you see it, right?
Now I see it, yes. Go for it.
That's better. Excellent. Thanks. So what you see here are 2 Java examples, which are too trivial to be true. So some find product by name method, get rating method, and you will call them sequentially to get the final result, which is the rating of this product. then you see this guy here, which says, yeah, of course, this is so easy, so why should I care? Things start to get considerably more complicated if you try to do this async. So if find product by name or get rating is on remote service, and you want to have optimal use of your resources, then you probably would prefer a non-blocking I/O to call this resource. And when you go down that road, then you need nowadays a reactive toolkit. So the example you see here, we are using CompletableFutures. And by doing that, you all of a sudden have to deal with a new abstraction. It's library code, right? It's not part of your language. So it's a library which goes viral in your whole code, and all of a sudden you have to master it. Whereas you basically just want to find product information by name and get a rating. But instead of that, you have to deal with then compose, then apply, then accept. And one of the other problems is in CompletableFuture, do it that way. When you use WebFlux in Spring, it's quite a different way. So you also will have to invest a lot of time to get to know all these reactive toolkits. And what's probably the worst about this approach is that from a performance point of view, it's perfect, right? You do non-blocking I/O, so no threads will be blocked. Your container application will use its resources really perfectly efficiently. From a maintenance point of view, that's really different, because simply when we look at what does this code express in terms of intent, it's quite hard to figure out what is my code doing, because you're kind of distracted of all these combinators like then compose, then apply, then accept, and so on. So to extract the gist of this code is quite hard. Kotlin has kind of realized that with the emergence of all these reactive toolkits, reactive programming is something that is reserved to a happy few, which understand the DSL, understand online concepts, but it's not something mainstream programmers do. I think that's still the case today, at least when I look around the environments where I come. Reactive is still a specialism, and some gurus know how to handle it, but not all programmers. Kotlin, they came with a great idea to make this a language feature, not a library feature. So what you see here is that instead of having this extra abstraction like CompletableFuture, you simply mark your methods suspend. And what that does is, in a nutshell, this will suspend some process until a result is there. And once the result is there, it will return the result. But this suspending and returning result is not something you have to care of. This is something the compiler will take care of. It will compile code that does that for you. You will never see this code. It just works. And the beautiful thing is that this looks like a synchronous signature, right? So name goes in, the product comes out. But in the underlying implementation, no thread will ever be blocked. So this is totally still async, even though you don't have the feeling it is. So this is how you would call the thing. And of course, there are some additional things involved you have to know about. And in the upcoming slides, we will explain how this all works, or more or less works in the limited time we have. But the bottom line is that when you read this code, it's not really more difficult than the sequential code in Java you've seen before. And as this guy said, even my boss understands it, then it's probably readable code. Therefore also maintainable code and so on. So what you get with coroutines is actually some reactive way of programming with the readability and easiness to understand, like sequential blocking programming, as most of us are used to. And of course, to make this all reactive, there are some things involved. You have a suspend method, you have launch, as you see. There are some primitives you have to know, but once you know them, you can apply them actually to every library and every problem you will encounter, and you can do reactive programming no matter what. So now let's go one level deeper and figure out what does suspend mean, what is this launch, how is it connected all together. And before we look at syntax, we first look at what are coroutines compared to other kind of concurrency primitives we have on a host system. So you might know on a computer you have processes. They're quite heavyweight. There are not so many of them. Then we have threads. That's what you're used to when you do a Java. So OS threads, so still an abstraction of the operating system you can make use of. And the point with threads is that this is quite an expensive resource. So what you see here is that per gigabyte memory, you can have 4,096 threads. That's how much memory a thread consumes. And the problem is when you start to block threads, then you kind of lock this resource that it cannot do something else, even though it could. It could process, but you block it. And this is actually the problem coroutines solve. So what we have here is coroutines, and you can have 2.4 million coroutines per gigabyte memory. So that's a considerable increase in parallel process you have. Coroutines are still executed by threads because on a GVM, as you might know, we only have threads. At least that's the way it's going to be since the beginning. And there are still some initiatives to maybe also implement something like green threads or another name they gave to it, but that's still not final, let alone clear when it will deliver. That's Project Loom, probably heard about it. That's more of an experiment than a serious thing that will happen in the near future. So bottom line is, with coroutines you can have a lot of asynchronicity, but then with actually no overhead involved. Now let's take a look and compare the two worlds, the thread world and the coroutine world. So what you see on the left side is a thread we create, and Kotlin has these nice extension methods that help you to create threads. So normally you would create thread.start and then give it a runnable. In Kotlin, you have thread and a function, it will do all for you, just a simple helper method. So you would create a thread. And of course, that's a very important concept you should be aware of when you work with threads. You have to join the thread. What happens if you don't call join? And if you had an audience now, I could ask a question and then you could give feedback. Maybe you can give it via the chat if you want. What would happen if you wouldn't join? I wait 30 seconds and then I say it. I see here a response. The code will continue in parallel. Will not wait. Main thread will end. Exactly. That's exactly great. Thanks. That's exactly what happens. So the main thread continues, whereas the other thread, the one we just started, will be killed once the main thread is killed too. So this program, the print line after 1 second, will never be printed. Only started you will get printed, then there will be no join. So the main thread just continues. He sees, hey, I'm at the end of my program. I will exit the program, kill all the threads that are still running, and that's probably faster than this 1 second. So after 1 second will not be printed. The coroutine counterpart looks more or less like that. And what you see here is that coroutines are created by means of a coroutine builder. That's an important concept you have to be aware of. At least when we look at coroutines from a bare bone perspective, when we move on to Spring Boot, you normally won't have to deal so much with these builders anymore because the framework takes care of you. But that's for later. So the first builder we have is this one, the run blocking. And guess what? Why did they call this run blocking? And then the blocking, the full word. Because it's an evil thing to do. We normally do never want to block in an application. Because when we block, we have the old problem that a thread, an expensive resource, will be reserved and cannot continue do processing because we blocked it. So this run blocking you should only use for testing purposes, where it's perfect, but when you encounter it in a production application, I can tell you, you do something wrong. But for now, let's stick to the fact that this is some sort of builder that bridges the thread world to the coroutine world. Within the run blocking, we can call launch. And launch really creates an asynchronous process, a bit similar to what you see on the left side with the thread, but then not a thread, a coroutine. And now comes the beauty with coroutines. Here, we don't say sleep, we say delay. But the delay method will not block for 1 second. No, it will be suspended. It's kind of, it will be parked, and then some scheduler will be scheduled, and after 1 second, the scheduler comes back and say, okay, where have I been? Okay, let's continue here and continue. Which implies that at no time in this little construct, anything will ever be blocked. So all the resources, so all the threads, the underlying threads that will still have to execute part of that, can do other work. So here we definitely get printed first started, and then after 1 second, we get printed after 1 second. Okay, so that was actually your first cup of coroutines. And we can summarize this with this example. And I ask again to the chat, dear chat, what do you think is the difference between the thread example and the coroutine example? What do you expect to happen? So what we do here in the first example is we create 1 million threads. And every thread we let sleep 5 seconds, and then we print a dot after these 5 seconds. So what will happen in the first and what will happen in the second? What do you think? Okay, excellent. I see Cliff Red and Bart having found the right answers. Indeed, the first one will make boom, because as said, 4,000 thread will fit in 1 GB of memory. When I started my GVM, I have 1 gig, I guess. Yeah, it will about 4,000 threads. It will stop. Let's see. I thought I have this example here somewhere. Main. I have here this piece of code. Let's run this one. Just that you really can be reassured that this code doesn't perform that well. Then we also prepare the coroutine code. This would be this snippet. Okay, so it's running. I created 4,000 threads, 4,000, 6,000. Yeah, I'll probably get some more memory. See, I get 2 gig of memory. That's why I get more or less 8,000 threads. And then this whole thing, I get OOM, indeed. And it's still printing some dots because some threads were still printing something, but it definitely won't come that far. So 8,000. Let's switch this with coroutines. And what we need here is, again, the builder, and we will talk about it in a minute. So this code won't compile because you really need this builder thing. What this is, as said, will enlighten you in a minute. So you see now the thing compiles. Let's run it. And as you can see, we've created in no time 1 million coroutines. They sleep, 10 seconds. That's a bit long. Huh? Okay, let's wait 10 seconds. Then you will see that the dots are printed here of all these 1 million coroutines. So far, so good. There we go. Boom. Happy peppy. Let's first take a look at the suspend function, because suspend functions are a kind of key ingredient of coroutines. As we said, the suspend function, you can really look at it like that. They can be paused, and at the later time, they can be resumed. And while they're paused, nothing will block. It's just like you reserve some work, put somewhere, and then at a certain time, you get something back from a network socket, or a scheduler goes off, or you get something back from a database. Once you have the result, the work will be taken again. It will continue at the exact place where you stopped, all without blocking. Suspend function have some limitations. The first is you cannot call it from a normal function. You only can call suspend functions from a coroutine builder. So we have the launch, that's a coroutine builder, and then you can call them because some context is required to make it work. Or you can call another suspend functions within other suspend function. So that's something you have to be aware of. And that's why it's important to get a better understanding of these builders. How do these builders work? More or less, as I said. We can go in detail till it starts to dazzle, but let's stick it to a level where you can go further with the exercises. So let's do some anatomy of a builder. And what we see here, these are the builder methods we will also use in exercise, and there are also not many more, but these are the most important ones. So you have this run blocking, launch, async. And as said, I just like to repeat that. Run blocking is only for testing purposes. Don't use it in your production code. Because when you run blocking, there will be a thread that will be blocked at the moment you start this coroutine, and then you have blocked the thread. And that's not a wise thing to do. Okay. Then we have the first parameter. When we created the run blocking in the example I just showed you here, run blocking, you didn't see these parameters, right? They all have default values. In Kotlin, you have default values, but when you look at the signature, as said, this is what you see in the slide. You have this context and this block, and they all have a default argument. And it's important to know a little bit about them. So the first one is the coroutine context. And one of the most important part of the context is the dispatcher. As said, coroutines still need a thread to execute. Coroutines cannot just execute or implement their own execution model. We still have we have threads on a GVM, and that's what we have to deal with. So somehow, inherently, we get some dispatcher, which is a thread pool eventually, which will execute a piece of code or will execute a coroutine. We also have an exception handler, the name, things like that. But I think for now, if you kind of realize, okay, we need some dispatch or some threading thing to execute the coroutine, I think for now that's fine. By default, you get this default dispatcher. And it's also wise to know a bit about the default dispatcher. The default dispatcher has as many threads as you have cores on your system. So if you have a quad-core machine, you will get 4 threads. Only 4 threads. We are not really used to that when you look, for instance, to serverless containers, because they always have about hundreds of threads to do the work because they block so much. But when you have an application that never blocks, you can do a lot of work with 4 threads because they never block. So once they, for instance, called such a coroutine, which never blocks, and coroutine is going to be suspended, it just picks up other work and continues. So these threads will continuously be spinning. So you don't need many of them. And there are quite some dispatches. Now we come to an interesting part, which is, imagine your code, your coroutine code, is still calling some blocking API. So you have some service class that does some blocking call to some blocking driver, which implies that the thread, so one of these 4 threads you have, would then be blocked. So this would be very detrimental for your performance. So you have to make sure that this never happens. And you can work around this, for instance, by using another dispatcher, which is the dispatcher.io, which has an underlying thread pool with about 80 and so what threads, which is a heuristic that should be sufficient. So for instance, then you have to be aware of. Another interesting one is the new single thread context. And that's, again, a tricky question I would like to ask you now in the chat is this one. So we had the example here with the default dispatcher. We launched 2 coroutines, and the only thing they do is they both delay themselves for 500 milliseconds. At 500 milliseconds, they print this statement which thread it is. And in this case, it's the main thread. It will always be the same thread that does that. And because we launch them in parallel, so 2 async processes will be launched, this will take about 400 plus milliseconds, this piece of code, right? Now we only have a single thread. Here we had, before we had the default thread pool with about 4 threads. Now we only have a single thread. How long do you think it's going to take now? Yeah, I see the advanced Kotlin users. 500 milliseconds, that's correct. Because, and there I will also answer a question which was already answered with the thread local and coroutines. That's a very, very good question, by the way. It still takes 4 milliseconds. Why? Because the thread, the single thread, will not be blocked. What it does is the single thread delays, calls the delay method, which then will schedule something, and after 5 milliseconds will wake up. It will continue and call this delay method, which again will schedule something that goes off after 5 milliseconds. After 5 milliseconds, this same thread will trigger the print line of 1 and print line of 2. So in the end, it still takes about 500 milliseconds. Also, if you only have a single thread. About the thread local question, that's a very good one, because all our containers are container frameworks like servlets, Spring Boot, actually by now all of these frameworks heavily rely on thread local. So every transaction context, security context, MDCs, for instance, if you do logging, probably heard of it, diagnostic context for logging, so that you can preserve a request ID through all your calls through this call stack. They're all put on the thread local. And yes, the good news is that coroutines, again with these contexts, have a means to port thread local state into the coroutine and port it actually to every, or propagate it to every other coroutine down there, even though different threads will execute them. So they really thought about that. This is in that sense an advanced thing. I won't go into slides right now. So the first answer I would give is yes, they really built this whole coroutine thing with context in mind. And there is a bridge between thread local context and coroutine context. And now the interesting comes, which I will just do a note and then I will leave it. In Spring Boot, when you use WebFlux, they have exactly the same challenge, because WebFlux is more or less based on the same principle. It's a reactive stack, so they also have few threads that do a lot of work and never block. And there they have the same challenge of how do we propagate state across a call stack from a logical perspective, even though this call stack will be executed by different threads. How do they preserve a context? And in WebFlux, they have created their own abstraction for that. And when you use coroutines in Spring Boot, you perfectly can use this context in every coroutine. We've done that in applications. So you still have some request ID you put on this WebFlux context, and in all your call stack, every coroutine you call, it's just there. So from that perspective, also transaction security context is just propagated. That's quite cool, because I've done Scala in some time ago, heavily by the way, and there this was really a pain to get this working. You had the K-mon, maybe you know this library, then you have to do all kind of weird things to make it work. And here it's just out of the box. It was a design concern, and they really solved this cleanly and perfectly. So let's move on. The other thing you should know a little bit more about, besides the coroutine context, is the coroutine scope. And I understand for the first time you see this, it's probably a bit fuzzy, but what you probably should take home from what I explained you is that the scope really makes life so extremely easy, because what it does in a nutshell is it prevents you from doing manual synchronization of different async processes. So in the thread example, you've seen that you have to call join to kind of join certain threads together to manage how different asynchronous processes interact with one another or wait to one another. Whereas in coroutines, that's done for you. And the vehicle that can accomplish that is the coroutine scope. And this has a term you probably heard before. This is called structured concurrency. Let's look at an example, what I mean by that. So on the left side, we have here the thread. On the right side, we have this interesting thing here. So we have this function literal receiver, and if you do the DSL and type-safe builder lab, the first lab, you will get to know more about how this construct works. So really work with this construct, so you get a better understanding of it. For now, I think it suffices if you know that this run blocking method has this block coroutine scope with this fancy dot and then column. What this does is it gives you access to a coroutine scope implicitly. So calling something within this block here is actually a call on the coroutine scope. In other words, when we say launch here, then launch is not some static method we invoke. No, launch is called on the coroutine scope, which is implicitly available. And what this coroutine scope is for launch, as you can see it here, it's the parent scope. Here we do launch, so we create another asynchronous process. So here we create a child scope. And the beautiful thing about this hierarchy is that the parent scope, as you can see here, kind of supervises all its child scope. So before its parent scope succeeds, all the child scope must be completed. And this is what is called structured concurrency. So in the thread example, we have to do this joining all ourselves. Here, we just can span a lot of asynchronous processes. And at the end of the method, so magically, it will wait till all the different asynchronous processes have been completed. Of course, if you want to do it manually, you still can. I won't go into detail for that, but you still can do your joining yourself if you really want. You have all the flexibility you want, but out of the box, you don't have to care about that. And that already, this part makes life with asynchronous processes considerably easier than using threads. So then let's look at another interesting one, which is the async builder. And the async builder is almost the same like the launch, except that this is what you see here. It doesn't just span an asynchronous process, but it gives you a handle where you can retrieve out a value. So here we say async, then you get back, in this case, rabbit, because this is a string return, it's a string. And then we can call here dot await. And again, we have this structured concurrency going on. We execute this code, then the execution path will be suspended here on await until a result is returned. So once await returns result, which is after 500 milliseconds, the code will automatically continue to execute. So also here, no joining or complex synchronization between asynchronous processes is necessary. Simply an await, and the coroutine magic does its work. Okay, so as said, this was the introduction of coroutines. There is much more. Maybe for you on the chat, what do you prefer? Do you prefer just to do the labs yourself? Is it worthwhile to go through another subject? Maybe Jeroen can do that for another one. I said it's just the beginning. It is just the beginning of the fun. It's getting more powerful with every slide. So it's up to you. What would you like to do? One more subject. Continue. Okay. Jeroen, do you want to do this next, or just tell me what you want?
I can do the next. That's fine. What subject would be the most interesting to pick up? Should we start looking into Spring, or should we talk about channels or flows? Yeah, I'm just maybe through the chat. We can have yeah, maybe we can see what the preference is. I see one Spring. Yeah. Well, it is JSpring, so
yeah,
maybe
exactly,
that would make more sense.
That's the reason why. That's the reason why. Cool.
Yeah.
Then the word is yours, Jeroen.
Okay.
So the Spring down the.
Yeah. So let me share my screen. I can find the right button. Yeah, you're able to see the slides now, right? Cool. Okay. Yeah. So building upon this this introduction to coroutines, this all sounds very cool and interesting. But yeah, let's see how we can use this in a real life application. So taking Spring Boot as an example, since yeah, that's a good tip. Presentation mode, indeed. Yeah. So of course, Spring Boot is a widely used web framework. So it would be really interesting to see how we can have coroutine support in a Spring Boot application. So that's what this part is about. And also,
sorry, Jeroen, we can't see the slides anymore. It jumped back to the.
Let me try again.
Yes.
Let me try to find the right window. Or I will just share the entire screen. That will also work. Is it better now?
Yes, that's better. Yeah.
Yes, thank you. Okay, so yeah, let's see how we can add coroutine support to a Spring Boot applications. So yeah, if you've done a bit of reactive programming, you maybe have used WebFlux before, which is based on the project Reactor, right? Using monos and fluxes, and Spring already has a nice integration with that. But coroutines also work on top of WebFlux. So to enable coroutine support, you actually need two additional dependencies, which are listed here on the slide. So you need coroutines core and coroutines reactor modules, and yeah, that should get you going basically. As you will see now, coroutines, as already Urs demonstrated quite well, will make reactive programming much easier than you might be used to. Yeah, having to use like additional libraries like Reactor. So Reactor uses mono as a primitive to handle asynchronous values. So mono is initialized lazily, as opposed to completable futures that you might be used to as well. And the good thing is, so yeah, in my experience at least, when using mono, it can quickly get in your way because you have to learn a whole new library concept. There's a lot of pitfalls which you can fall into when dealing with monos, and when using coroutines, you don't even have to worry about mono at all anymore. Oh, that's the nice thing, because every function that used to return a mono now becomes a suspend function. So you don't have you're getting rid of this mono wrapper around your types. You just get your normal types back, or a normal exception is thrown, like as a classic Java developer you're used to. So you're programming reactive asynchronously, but you don't even have to be aware of it necessarily. So that's it really makes life much easier. Yeah, so we can completely get rid of the mono abstraction, and you have normal function signatures again. The only difference is that you have the suspend keyword added to your function definitions. So if you want to make remote calls to remote services, you need an async I/O client. Also in the exercises, we will be using web client for this. There are many others available, but I think web client is the most commonly used one. So web client is I think a nicer replacement of also the popular library, the REST templates from Spring, because that's fully blocking, and web client supports non-blocking I/O. So that's yeah, that's pretty nice improvement. And this works also well with Reactor, but also with coroutines. So how would it look like with Reactor to use web client? Well, basically, if you want to make a call, so you say web client create, or you fill in your host value. You want to do a get. You have a certain URI, and then at a certain point you call retrieve. And the retrieve will by default return one of the reactor types, mono. So in this case, we retrieve a URL of a random avatar. How would this look like if you want to use coroutines instead? It actually looks pretty much the same, except we have one additional call. So there's a helper method called await body, which will basically turn the mono into a suspend function. So now our random avatar method becomes a suspend function because we call await body. So now we use the async await pattern again. And the nice thing is, as you can see from the signature, the mono type is completely disappeared. So here we're just returning our URL type. So under the hood, still mono is being used, but as a programmer, we don't have to worry about it. We're not even have to be aware of it. So await body is one of the available glue methods. There are multiple. And here's an important side note. As Urs already advised against blocking in general, don't use run blocking in production code. Also don't use retrieve.block because that will also work. That will also give you the URL, but then your code is blocking and it's not relying on coroutines anymore. So don't do that in production. So in any enterprise application, you would have to access a database as well. So how would you do that in a reactive manner? So JDBC, as you probably know, is a blocking driver. So we need a different one if we want to be fully reactive. So there's a relatively new library called R2DBC, which actually which is actually an async driver, and many databases are already supported. Postgres, MySQL, C. Not all of them yet, but I think it's coming. Yeah, so if you really want to be truly reactive, you should avoid using JDBC and rather look into something like R2DBC or alternatives. Yeah, Spring Data has a lot of helper classes that can make life easier for accessing repositories, accessing databases. So it has like the CRUD repository interfaces, but it also has like the reactive variants of it. So, for instance, reactive CRUD repository, which will work with the reactor types again, so with mono and fluxes. So you can define a method like this on your interface, find by username. It returns a mono, and Spring will generate the implementation for you, as you might know. So you don't have to maintain that part of the code. But of course, here we want to get rid of the mono type again, because we don't want this abstraction. So luckily, there's also a coroutine CRUD repository. And instead of the mono type here, again, much similar to the avatar function that we saw before, you get basically it turns into a suspend function again. So here we're getting the instead of a mono type, we're just getting back our user type. And since of course this user doesn't have to exist, we return the nullable type, so it can be also null. So if you want to use coroutines instead of the monos, you just need to use a different interface. So the Spring support is already pretty good for that. And if you just remember, if you add any custom queries, also mark them with suspend, so it will be a smooth experience. So this should be this challenge 6, I think, by heart, is about this part, accessing a database. So this should get you going with that. Should we do one more topic? So we also have the track about using coroutines in your controllers. You can also go over that. Yeah, I see coroutines over controllers. Yeah, we can go into that. I see a question. So we can't use ORM with Spring Kotlin suspend.
That's correct. I mean, in that sense, they don't suspend. They use GDBC. There will be a blocking call by GDBC in the end. Also, GPA hibernate in the end. It boils down to GDBC. You could do that, but then you would have to run these different dispatches, and that's not normally what you do in a reactive system. So you have to rely on the R2DBC Spring Data framework that is used. There are also other ones out there. Kotlin has some other frameworks with that, but you cannot rely on your GPA and Hibernate. Having said that, you of course can use GPA and Hibernate within a Spring Kotlin application. That's perfectly fine, but they don't play well with coroutines. We do that, by the way. We use also GPA for our, for instance, we have some back office applications. They don't need that tremendous speed you would get when you have, you would get with Reactor application, speed and of course scalability. For these cases, we also rely on the ORMs, but for the applications where it really matters that they're resource efficient, we use the other the R2DBC approach. Shall I take it over, Jeroen? Or?
Yeah, that's fine.
Okay.
I heard that people are interested in to see how to use coroutines in the controller, so maybe
okay, cool.
You can do that part.
Fine.
Cool.
So that would be here. I guess you can see my screen or not?
Yes.
Okay, cool.
You can see it.
So within controllers, it's more or less the same story. So normally controllers, especially when using WebFlux, will return monos for still single results. If you stay a bit longer with us and we go through all the slides, and you'll see that then you can also return streaming results. But mono is the single value abstraction or exception. So this is what we see here. If you want to have reactive endpoint in Spring Boot with WebFlux, you simply return a mono string. And what you also see is that once you go the mono route, you have to go it all the way. With coroutines, it's quite simple, as already Jeroen pointed out, in many ways with the web client, with the dials, you simply mark method suspend, and that's it. So from then on, because it's suspend, you can call delay, for instance, and off you go. Okay, there is a question. Maybe before we continue, we can try to answer it. I have another question. If you have multiple coroutines but don't know which one will finish first, what can you do here? So you have different asynchronous processes, and that's kind of normal thing, right? So when you have different processes, then you don't know which one is finished first. What you can do with coroutines, I haven't talked about it, is you have cancellation. So say you have 3 coroutines and then you get a result back, you can cancel the others. So and this also simply works with exceptions that are being thrown. So it relies on the normal standard mechanisms of the language. A, B, C. If I understand correctly, okay, fine. Okay, let's continue with the slide. It's definitely a good question, and that's the nice thing of these virtual conferences. You have to. The challenge is also to communicate with one another. So what you see here is an example that fully makes use of monos, and we know clients that use WebFlux in their business applications, and as you can see, it's not really a pleasant thing for your eye to look at this piece of code. You see a lot of distractions. So all these mono things you see in different combinators. Here we see zip all of a sudden. What is zip? Zip we normally have with collections, and I also have a mono zip. What does zip do? You have to go into the API, see what does zip do. And whenever I throw an error, I simply cannot throw an exception, because this would be an exception on the thread that executes it, which will never get back to the user. So you always have to wrap everything within the mono. So once a mono, always a mono. And that's a nice article Jeroen wrote some time ago about the 10 pitfalls in reactive programming. I advise you to read it. Using monos, you really can shoot yourself in the foot very, very easily. It actually almost invites you to make things wrong. The good news is when you use coroutines, yeah, what you see here is just kind of normal code, right? All these distractive abstractions are not there. You have normal method calls, random avatar, verify email, you would have in normal blocking applications. And the only thing you have to rely on is the suspend keyword. And once you have suspend, you also can use all the normal language constructs like if, else, when, throw, try, catch, and it will just play nicely with the asynchronous context you're actually in. So Kotlin really does a tremendous great job to hide all the way these nasty abstractions you normally would have to use if you go the reactive way with a library. With coroutines, it's just gone. And we also have a subject we haven't treated yet. We can also do it where you can see how easily it is to bridge different asynchronous worlds to coroutines. It's really a piece of cake. It's kind of magic, right? That you have WebFlux, and in other cons you have CompletableFuture, and it just works. And they made it particularly simple to bridge these different kind of asynchronous worlds. So also compared to Java, because I also have some people that are new to Kotlin, what's also beautiful is, for instance, here in the Java example, if we want to create a copy of our user, we most probably have to rely on a builder. Create some builder code, maybe you can generate it, but still, it's, again, a lot of code you have to create just to do something simple like change an attribute of a user. Or do everything mutable, but we know that mutability is, yeah, doesn't really make our code safe. What we do here is we use, for instance, .copy. That's a method you automatically get when you have data classes. So user is a data class, which is automatically the equals and hash code is implemented. And you might say, yeah, Java has Java has record classes. It's in 17. That's correct, but the record classes don't have a copy. So you still get some sort of immutable construct in Java with Java 17, but no copy. And what you normally do with business application is exactly that. You take some immutable state, then you convert it to something else, because that's what you do in business logic. And by having copy, that's really a piece of cake. So the interesting question, what's the coroutine scope in which these suspend functions in a controller run? And that's a nice thing. The scope is done for you by Spring. So Spring, of course, has some code that scans these annotations. And once you get from the network layer, you get some request. It will make a request object. And then there, somewhere deep in the Spring core, a coroutine scope will be created with a launch. So you literally get a .launch, and this will be on a global scope. We haven't talked about it because otherwise it's getting too big, but you can't just starting scopes right away without run blocking. And this is the scope that will be presented to you. And I think this question is a good one also for the next slide. So the code, this code is not really the same like that code, in the sense that here we have structured concurrency going on. So we have this random avatar, which does its work asynchronously, right? Non-blocking. But because we have structured concurrency, the code will wait that the avatar URL is available before executing email, verify email. And that's something you're probably not aware of. You think in a sequential world, that's the most normal thing. But in an asynchronous world, that's quite an achievement that you just have this out of the box. This is also actually what you see here, probably without noticing, is that this is structured concurrency in practice. In the Java example, you have the .zip, and .zip actually makes sure that these two services are executed in parallel. So you could say, okay, this is inferior to what we've seen in the Java example. That's not really correct, because if you want asynchronicity, it's quite simple to do. But you have this fancy helper method called coroutine scope, and what this coroutine scope method does is it actually gives you the scope in which the suspend method was executed. So then you could create your own scope if you want, or you just continue with the scope you got, and normally that's sufficient. And then we have our async keywords, where we can say, okay, execute this service asynchronous. These statements will continue until the first suspension point is hit, and this would be here await. So here the code will be suspended. It will either throw an exception, then it will continue await here, and probably because you already have called the URL here asynchronously, the result will right away be there and could then be returned. So this is how you quite easily add asynchronous constructs into your code. So now we have some more questions in the chat. Let's see. Okay. And to come back to the question asked earlier, can I just do something like request context holder in these suspend functions? And the answer is yes, you can. And you have to use the WebFlux. I think that's the WebFlux request console. It's already 3 months ago since I've implemented that at my client, where I also had to put some context on the WebFlux context. And then in your coroutine, you simply do an extension method on the coroutine scope with the state you want, and you just retrieve it as if it's magic there, as if you have a thread local. So these worlds are perfectly bridged together. And yes, you can use the transactional annotation there. The Spring team really does a great work to make this coroutine experience a wonderful journey for us developers. And things like transactional just simply work. So they will make sure that once the thing is, once this annotation processor hits a join point where you have a transactional, that all the wrapping is done nicely. What does not yet work, at least I've looked at it about 2 months ago, is AOP. So if you have your your normal aspects within Spring Boot, this is not working yet as it should. And they're working on that, so it's a question of time until this is coming available. And the transaction, that's a nice thing about transactional, because in WebFlux you also have this notion of a context that actually is set on the request, which travels through the whole stack or through all the asynchronous calls. The transaction is also put there, and they made this possible that this works as if in a normal blocking application. It's quite remarkable that they achieved that, and great for us because you just mark it transactional, and it is transactional. If you do the labs, you also see that transactional is there and that it works. So at request scope also works. I guess so, in the sense that it's quite easily to have some extension method that gives me, for instance, the request. If I put the request on my context, I can get out anything I want. If particular request scope would work, I think, I haven't tried it myself, but I think it should work. Yeah. So the only limitation I've encountered so far, and we have this stuff running in production, is that, as I said, AOP is not working. So instead of AOP, we then use our own wrappers. So like here, the Coroutine scope, we also have some explicit methods which have then a function and where do you think that works fine. And as I said, it's a question of time to resolve. And for the rest, everything just works, which makes reactive all of a sudden not this huge threshold you have to go over, but a very pleasant experience. Okay, cool. So time left, 50 minutes. Which subjects you want to still have treated? Yeah, this is Anja Bar B. Just ask how about logging. So if you have this MDC, the diagnostic context you normally have on a request or on the thread local, as I said, this just works. So it just works in the sense that WebFlux has this context that travels through a whole request. And if you have state that you need to preserve for a whole request, then you can put it on this context, and then it's available in every coroutine you will execute. And that just works, yeah, just works great. Okay, so what do we have left in terms of subjects? Let's take a look. So we could take a look at the interop. So how is it possible that coroutines so easily play perfect in harmony with different asynchronous or reactive libraries, like we've seen here, WebFlux or CompletableFuture? You could, if you want, take a look at that. You also can go a step further and look at these flows where you can create, or channels, maybe also flows where you can create streaming APIs. It's up to you guys. It's 30 minutes left, and we like to talk about all of them, so that's not an issue. Flows, I hear. Part wants flows. I see more thumbs up for flows. Okay, then I give back the mic to Jeroen for flows, and I assume in Spring Boot, right? Or just flows from the basics? Okay, flow in Spring. Or maybe you do both of them, Jeroen, maybe a bit theory and then in Spring, because there are not so many slides.
Okay, let me check, yeah.
Yeah, there are not so many slides for... Yeah.
Then I will share my screen again.
Yes.
Present. It's visible now, right? Yeah. So, what if you would have a stream of infinite values that will be available over time? How to deal with that? Is there a primitive for that? Because, yeah, we've seen how coroutines make reactive programming easier. But do we also have a construct in Kotlin that makes dealing with like infinite data streams easier? And the answer is yes, because we have flows. So this is basically the construct. This is how you would build a flow. So you have like a flow builder, and in a flow actually represents a non-blocking stream of data. So it's kind of like a sequence, what you would have in Java. So the interface is quite simple. You have a suspend function that can collect data elements using a flow collector. So yeah, this is again the builder method to be able to create a flow. And you can emit values using the emit function. And again, this is also a suspend function. And we can also use normal suspend functions that we already seen before, like for instance, the delay function here. The difference with a sequence is that a flow is asynchronous. So it allows the calling of suspend functions within its builder and within the flow operators. So that's the nice thing. So we learned that you can only call suspend functions from other suspend functions or from within a coroutine context. You can also call suspend functions from within your flow context. So how would you consume a flow? So here on the top, we've created a flow. We emit two values with a delay in it. If you have access to the flow, you can use all sorts of operators on it, like transformation operators, commonly used, like filter, map, collect. So you can filter a flow using a predicate. Like in this case, we only want elements that contain the tilde symbol. Then we want to transform the element to uppercase, and in the end, we have a terminal operator, like you also have in the streaming API of Java, where you say, okay, now I did all my transformations. I want to collect all the values that are emitted, do something with it, add it to a list or print it out. And this, the terminal operator calling that will actually activate the flow code. So just defining the operators, like calling the filter in the map, doesn't actually activate the flow. So nothing will happen until you actually call one of the terminal operators. And that's why we call them cold streams, basically. So flows are so cool. Yes, they're cool in both senses of the word. As long as no terminal operator is called, nothing will actually happen. So we can register all kinds of hooks, do a for each, do the filters. Nothing will happen yet until we actually say collect, or in this case, toList. toList is also a terminal operator. And that will actually trigger the execution of the flow. Yeah, so as mentioned, flow is a cold source. It is not active before the call to a terminal operator, and it's also not active after the flow is fully consumed. So it doesn't leak any resources. It releases all resources before returning from the call. So that is quite nice. And as you can see, it's quite easy to use. So yeah, you've probably heard about back pressure. This is like very much discussed term also within reactive programming world. Many reactive libraries have back pressure support built in. So what is back pressure in a few words? It's basically when a consumer cannot keep up with the data source. So it cannot keep up with the incoming data that is sent by a producer. The consumer can send a signal to the producer, hey, please slow down the rate because I cannot keep up. So that is basically the basic concept of back pressure. You can also see it, you can picture it as like when you grab a hose in the garden that runs, water runs through, but when you squeeze it, right, then the water stops, right? Also, there won't be any more water filled in the hose from the tap because you apply back pressure in the most literal sense of the word. Sorry. So as mentioned, in traditional implementations like ArcJava, Reactor, also in the Scala world, this signaling, this back pressure mechanism, is achieved using a back channel. So instead of just the producer just keeps sending the data, the producer can only send data when the consumer signals that he's ready for more data. So it basically, the consumer basically sends a signal, give me 10 more elements, and give me 10 additional elements. And then the producer is allowed to send more. So that signaling goes through a back channel. So this is also called the push-pull hybrid approach. And there have been very basically all the libraries have like complicated implementations to deal with this logic. So if you see it in the picture, so the subscriber and the consumer basically request 5 elements, so it signals to the publisher through this back channel, hey, give me 5 more elements, and that is a signal for the publisher, the producer, to send new items. So usually this is called on next. So what does this look like with Flow? Does it also need this back pressure mechanism? And the answer might surprise you, because it actually doesn't need it. It doesn't need such a complex mechanism, because it relies again on these powerful suspend functions that we've been talking about for more than an hour now. Because they inherently support back pressure. They can be paused, right? So when a consumer of a flow is overwhelmed, it doesn't need to signal. It doesn't need to signal the producer through a back channel. It can simply suspend the emitter, and when it's able to process more elements, it can just resume the function when it's ready. So it's in full control, and it doesn't need any separate mechanism like a back channel to do that. So the emitter, the producer just emits elements, and this emit function will just suspend. It's a suspend function when the collector is getting overwhelmed. So this is the basics. This is the basics of the flow construct. There's again a challenge for this, which you can take in your own time. I see we have a couple of minutes left, so maybe we can still quickly look into how this would look like within Spring.
Yeah, let's do it. I've already posted our feedback form, because we really would love to hear from you what you've learned, or where you struggled, and so on. So I put it in the chat. This is the URL. So we would very appreciate it. It would appreciate it a lot if you could fill it in, because this is the way to make our story even better, or just improve certain things so that it's for others getting easier. Thanks very a lot. So now back to you, Jeroen.
Yes, thank you. And yeah, please fill in the survey. We can't stress it enough. So flow support in Spring Boot. So Reactor, we already seen the mono type of Reactor has another type for infinite streams, which is Flux. So it's like the reactive counterpart of a collection. You can see it. And when using coroutines, well, you might have guessed it, Flux actually becomes Flow. So that's the change, basically. And well, that's not the only change, because it's also easier to manage than Flux. Flow has just only a few methods compared to Flux. It has, I think, like about 30 different methods you would have to deal with. But Flow only has flow, well, the builder, an emit function to send elements, and collect, basically the terminal operator to collect data elements. So it makes working with it way simpler than with Flux. So again, the coroutine CRUD repository that we've looked into before. Before we saw where you have a function that only returns one element. If we would use, for instance, a greater than function in this case, instead we would return a flow of users. And it doesn't have to be a suspend function. So that might be a little bit tricky. But yeah. And yeah, again, if you have custom query methods, always use the return type flow if you can return any arbitrary number of elements. So don't use Flux if you want to stay away from this reactor world and want to keep it simple. Use flow instead. So in your controller, you can also simply just return flow, and Spring will do the rest for you. Spring Boot knows how to handle the flow type. So under the hood, much like it was for Mono, like the suspend function under the hood still uses Mono. In this case, the flow under the hood will be transformed to a Flux. So you can use the flow builders to generate an infinite stream of data, for instance, and return that through your controller, simply like this. So here we're just emitting an infinite stream of numbers, and it will just work. And you can use the very underrated technology server-sent events, I would say. I think it exists for quite a long time, but I think it's quite unused. It's super powerful technology, and it works quite well with flows, like with infinite streams. You can just have an API that supports server-sent events, and you define it as a flow. You have a generator that generates some data. Here we are generating your lucky numbers infinitely, and you can just consume it with any HTTP client. So yeah, the only important thing is that just set the right content type, event stream. And any HTTP client can just consume this infinite stream. For instance, with curl, this is what you would see. And I think the last challenge is about this. Yes. So challenge 8 is that by heart is about building your own SSE endpoint. And you can simply consume it with curl or with the web client that we looked at earlier. I think, yeah, we're almost out of time.
We are out of time.
Yeah, we are out of time already.
At least that's what it says below. You are out of time.
Well, cannot be much clearer than that. I will stop sharing my screen. The web IDE environment will be available still for a couple of days. So we understand that it's really, it's not enough time to do all the challenges, but you can do it still at your own pace at a later moment. We really hope you really enjoyed it and learned a few things. I really liked doing this, and thanks.
Yeah, thanks too. It was indeed a great experience. A bit weird. Normally you have a room where you have contact with people. So this was first time we do a workshop remotely. I think with the presentation mode, you still captured some information. It's definitely worthwhile to do the exercise, because then you really get a hands-on the feel of how this stuff works. We were very enthusiastic about it, and I promise you that when you do the exercise and you get this real feel, that it's very surprising how powerful and easy these concepts are using Coroutines, Kotlin, and Spring Boot. So, and hope you got enlightened. We train, of course. So if you think your company that we could help your peers to bring you to the next level, then you know how to find us. Shameless plug on our side. But as I said, also thanks a lot for your great interactions. We still had the feeling that real people were listening and were asking good questions. So thanks a lot for that. And yeah, enjoy the rest of JSpring, which is, I guess, one more session and then it's over. And see you maybe JFall or the next year again. Thanks a lot.